Okay, guys, today we're going to go over section 5.2. The name of this section is called the binomial distribution. So recall that on section 5.1 we were talking about probability distributions, and that in order for us to make sure that that distribution, that probability distribution table was correct, it had to fulfill two requirements. One was that the sum of the p of x had to equal to 1, and each of your p of x values had to be between 0 and 1. Well, this is going to be one of many distributions that we're going to talk about. And the first one is called the binomial distribution. So let me give you the definition. And so this distribution also has requirements. All right, so the binomial probability distribution allows us to deal with circumstances in which the outcomes belong to two categories: heads, tails, acceptable, defective, survived, died, success, failure, pass, fail. It has to be two. That's why it's called the binomial, meaning two, like bicycle. And so the definition of it says that the results from a procedure that meets these four requirements. So here are the four requirements in the yellow box, right? The yellow box. And so the first one is that the procedure has a fixed number of trials, all right? And then the second one, second requirement says that the trials must be independent, meaning that the outcome of any individual trial does not affect the probability in the other trials, hence independent. Number three, each trial must have all outcomes classified into exactly two categories, just like we mentioned: pass, fail, good, bad, on, off, heads, tails, boy, girl. It has to result in two categories. Now, in this section, those two categories you're going to be using a lot, and use that in the real world, is success and failure. So the fourth one is that the probability of success has to remain the same in all the trials. All right, so let me give you a real life situation where this is used. So we visited the Toyota plant nearby our home, and they gave us a tour of the facility. And so they use the binomial distribution when they're constructing the Tacomas. So when they're constructing the Tacoma trucks, of course, they have a procedure. They have a fixed number of trials that they have to do, right? They have a quota. They have to build a certain amount of trucks per day, and I believe it's 200. So and then number two, when they're assembling a truck, we have different departments. When they're assembling a truck, one truck is made and then the next one's made. So each truck that they make is independent than the next, right? So they got to create one, go to the next, create one, go to the next. So each truck is independent. The third, each trial must have all outcomes classified into two categories. So after they complete the truck, either the truck is a success, they build it correctly, or it's a failure, there's a defect. So those are the only two outcomes that can occur. So good or bad. And the probability of success remains the same in all the trials. So yes, there are machines now. They are replacing humans and building the Tacomas. So if the trials are not being made the same, that means that the machine is going bad. So they're going to have to adjust it and so forth. So a plant making an item fits a binomial probability distribution. Okay, so the formula that we use, we're not going to use it in here, but this is the formula that we would use if we were to do it the long way. So there is a formula right here. It looks very foreign. It looks very difficult, but it's not. So before we used to do the formula, so if you're noticing that there's a exclamation point, that is because that exclamation in stats is called a factorial. So what is a factorial? So a factorial, you should have a button in your calculator that has the factorial button. And I'll explain to you what a factorial is. So let me show you on my end, on my calculator, where the factorial button is at. So the factorial button, if you have a TI-30XS, it is right here where it says PRB. You first you have to put a number in. So I'm going to put 4, right? And I'm going to hit PRB, and it should be the third option. I went too far. There is 4 factorial, and you get 24. So what factorial is doing is that it starts with 4, and it multiplies 4 times the numbers before it, all the way down to 1. So you would start with 4. So it would be 4 times 3 times 2 times 1. And that's how they get to 24. So a factorial is the value multiplied to its previous numbers, all the way down to 1. That's what a factorial is. So on the calculation, the formula uses that function. It has it on the numerator, it has 2 on the denominator, and then you have values that are raised to the power. So again, we're not going to use the formula. We're going to use the statistical software StatDisk, or you can use Excel, whatever software you have can create or can compute this formula. So the only thing you need to know in order for you to use this formula, because we're going to be dealing with a lot of word problems, there's going to be 3 variables that we're going to have to know, and you're going to have to read the problem and extract it from the problem, and you'll have to identify 3 of them. So you're going to have to identify the n. So the n represents the number of trials. Usually it's the total number of trials, right? You also are going to need to know P. I'm going to go out of order than what the green box has, but you're going to have to find P. Now P is going to represent the probability of success. Probability of success. And usually it is in a percentage. So you will have to change it to a decimal. Convert to a decimal. If you're going to use Excel or StatDisk or anything else, it needs to be converted to a decimal. Very important. Okay. And then X. X is going to represent the number of successes in trials. Okay, we don't need P, but I can tell you that P and Q are complements of each other. So if you know P, you can find Q. So let's say P is 0.4, Q has to be 0.6. P and Q have to add up to 1. They're in decimals. So if you add the P and the Q, it's supposed to equal to 1. So if P is 0.3, Q must be 0.7. So P and Q are our complements of each other. So in order for us to use, we're going to use StatDisk. We need to extract these 3 numbers. The n, or 3 variables, the n, the p, and the x. You need to know how to extract those from the problem. So I'm going to show you back in section 5.1, there is a problem that we went over dealing with couples that were planning, or we're going to have, the couples were going to have a baby. The mom was going to have a baby, right? The wife. and the hospital was keeping track of the, the genders of the kids, right? And so we had this table, and I told y'all that we didn't have to worry about how did they get the P of X numbers. Well, the P of X values are from the binomial distribution. That formula produces all of the P of X values, all of them for us. You plug in 0, you plug in the P, the Q, and the X, you will get your P of X for each of those random variables, 0, 1 through 8. That's how they got those. So I'm going to show you all how did they get these P of X numbers using StatDisk. All right, so we're going to go to StatDisk, and I'm going to show you. So we go to StatDisk. Okay, so when you go to StatDisk, you are going to find analysis. You're going to click on analysis tab. You're going to click on probability distributions. You're going to click on binomial. So analysis, probability distribution, binomial, and you should get this window. All right, so on our notes, if you all go to our modules page and you scroll down to notes on StatDisk, you can print out the chapter 5 notes on how to use StatDisk to compute the binomial distribution. So here's the page. So I encourage you to download this page. So, and you're going to write notes on it. Right. So let me show you how it works. So I'm going to zoom it in. But mine's a little bit different because on the sheet, this one is the downloaded version of StatDisk. The one online has it different. You have this portion on the left side of the screen, and then you have this part on the right, and then you have these below it, the box. So it's a little bit different, but this is cool because it shows you everything on one page. All right, so what you have to do is there's going to be 3 windows that you're going to fill in. So you're going to fill in this box the number of trials, total number of trials. You will have to fill in the p-value. It's got to be in decimal, as you recall. And then this number, I will not tell you, but it's a secret. It's a special button. All right. Okay, so let's go to our StatDisk, and I think I showed you how to do it already, right? How to go into it. Click on analysis, probability distribution, binomial, and we're gonna fill in the box. All right, so and then that exercise that we did, it dealt with 8 couples. So your n is going to equal to 8. So there's your 8. Right? And then the probability. What's the probability of a boy or a girl have a couple of, pregnant woman having a boy or girl? Well, it's 50-50, so that should be 0.50. And I hit evaluate and presto. you get the table. Now, do not look at these numbers on the side. These 1, that 2, that 3 on the very far left are basically labels for the rows. So ignore. I wish we could just delete these numbers on the far left. Ignore these. This is what you want to look at. You want to look at these 2 columns, the X and your P of X. Now, if you look at our X and P of X and you match it with the one in the book, you will see something different. Here's the one in the book. Here are your P of X. Notice that the P of X values have been rounded to 3 places behind a decimal. Well, in StatDisk, it didn't do that, right? So you will have to round your P of X values to 3 places. So these 2 columns are your probability distribution. table. It creates your probability distribution table. Now notice there are two extra columns next to the P of X. What are these? Well, notice how these numbers are going. If you look how, if you scroll from this number down to there, what do you notice about the values? We covered this in chapter 2. You remember cumulative probabilities? Cumulative probabilities. So remember in cumulative, they start accumulating as you go down. So remember, this was moved over, and then you add these two values to get to this number. You add these 3 to get to that number. You add these 4, I can't click on it. You add these 4, it won't let me do it. You add, it's not letting me do it. All right, let's try it again. You add these 4, it won't let me do it. Anyways, you see that you keep adding, they keep adding. There you go, 1, 2, 3, 4. You get that number. You add. That won't let me do it. It won't let me do it. Anyways, you get the picture, right? It's accumulating as you go down, and sure enough, you get 1. The last column is reversed. They just transposed it. The top goes there, and then the bottom's there. It's pretty much the same. These values are the same, but they're going in descending order. These are going in ascending order. It's going up. These are going down. All right. So those are cumulative. Cumulative counts. Those are going to play. Those are going to come into play when we do the exercises. Now, notice that we have titles on our columns. This column was your random variables, X. This is your P of X, your probabilities. So we're going to title them. So because we're going to do word problems, you are going to have to title the column. So if you have a handout copy of it, what I want you to do is you're going to label, don't label the random variables. You're going to label your P of X, and on top of the P of X, you're going to put the word exactly. All right. This is the exactly column. Okay. The third column, we're going to label that as at most. This is the at most column. Okay, that's the at most. The last column, we're going to label it as the at least column. Okay, so if you see these specific words in the problem, you're going to identify the value within this column. So suppose that we say find exactly 3, right? So you go to 3 and you go to the exactly, and bam, there's your answer. If you round it to 3 places, it would be 0.057. Okay. If I ask you to find the probability of at most 4, so you go to 4, right? And you go to the at most column, and there's your answer. If I round it off to the 3rd place, it would be 0.999. Okay. If I said find at least 1, you go to 1, you go to the at least column, boom, right there, and round it to 3, which would be 0.651. Okay. So that's how it works. So you have to write these terms on the paper. You get to use that in the test. All right, you don't have to memorize them, but that's how the procedure works. Now, I'm going to show you this little button later where you don't have to see all of the columns. If you put a value there, what it'll do, it'll just display that specific row number and these numbers. And then you just have to choose the one that you need. You don't have to see all the other numbers. That's the beauty of that special button. And I'll show you all in a little bit. Okay, so let's practice. Okay, so we're gonna go and do some of the problems in the book. So we're gonna go to page. Let's see what page is the homework exercises in. I think I went to. Oh, that should be it. Okay, here we go. We're going to do number 15 through 20. 15 to 20. All right. So again, your goal is to identify the N, the P, and the X. Okay. All right. So problem number 15 says, assume that random guesses are made for 8 multiple choice questions on an SAT test, so that there are N equals 8, each with a probability of success given by P equal 0.2. All right, so I already know for number 15, I know my N is 8. My P value is 0.20. And I think number 15 is going to give us the X. It says find the probability that the number X of correct answers is exactly 7. All right, so you got to make sure that you write down the term that's describing the 7. What is the 7? Is it exactly? Is it at least? Is it fewer than? Is it at most? What type of 7 is it? Oh, it's exactly. Exactly 7. All right, so I want to find the probability. So I'm writing P parenthesis exactly 7, and I'm closing the parenthesis. And I'm writing it like this. This is how you write a probability. So you write capital P, parentheses exactly 7. And now I'm going to enter these values in StatDisk, and I'm going to round this number to 3 places. Okay. All right, so here we go. Your StatDisk. Okay, I need to clear it. Do that. Okay, here we go. So if N is 8, P is 0.2, and I'm gonna put the X value. I'm gonna put 7. Right? So I hit evaluate, and presto, it gave me the line that has the 7 as my random variable X. All I have to do is now find the value that corresponds to the column that was labeled exactly. Ah, it was the second one. The second one, the P of X, had the exactly label on top. So there's my number, and I got to round it to 3 places. Notice that there are more digits way at the end of the zeros, which means my answer is 0 plus, because it's a very small number. So my answer for number 15 is going to equal to 0 plus. All right, 16. All right, 16. 16 says, I think we have to use the same values. Yeah, that's right. So n is 8, p is 0.20, and x is, it says at least 4. At least 4. Okay, so at least 4. Okay, so I'm going to go to stat disk in a minute. Let me write down my probability. So I'm going to write probability parentheses, and you write the description of what you had for x. X was at least 4, close parentheses. Okay, there's my, that's how I write my probability. And now I'm going to enter these numbers into stat disk. So someone's asking me about at least. What does at least mean? At least means that is the smallest value that it can be. It's the smallest. That's the minimum that it could be. At least. At most means that's the highest. That's the max that it could go. All right. So let's see. Let's go to stat disk, and I'm going to enter my numbers, 8.2, and I'm going to put 4 here. Right, and now it gave me the row containing the random variable 4, and so now I gotta find the value that corresponds to the at least. Is it the second, third, or fourth? At least. That is correct. The last one is at least. So I gotta round that number to 3 places. So my answer is 0.056. You all can change it to a percentage. That would be equivalent to 5.6%. Whatever you feel comfortable with. If you want to round it to 3 places for the decimal, that's fine. Or you can convert that answer to percentage. Okay, let's look at number 17. Okay, 17 says, find the probability that the number of x of correct answers is fewer than 3. Okay, fewer than 3. All right, so I'm using the same thing. N is 8, p is 0.20, and x equals fewer than 3. You got to write the description of what they're asking us to find. Fewer than 3. So I need to find the probability p parentheses fewer than 3. Fewer than 3. Fewer than 3. Now, if you recall, I don't think I have fewer than 3 on my sheet. I do have x for fewer, but I don't have fewer than 3. It's gotta say those exact words. Fewer than 3. I don't have it. I don't have fewer than 3. It's not there. It's not on the titles, and it's not here. All right, so we gotta think. We have to think. What does fewer than 3 mean? Fewer than 3 means it's less than 3. It's smaller than 3. So let's write down the numbers. What numbers are smaller than 3? You don't include 3. It doesn't say including 3. It just says fewer than 3. So fewer than 3 means 2, 1, and 0. So what I'll have to do is I'll have to go to stat disk, and I'll have to find the exact values for 2, for 1, and for 0, and I have to add them. Right? So let's go to stat disk. I'm going to put 8.2. I'm going to take the number out. And what I have to do is I have to add, because it's fewer than 2. So I have to add those 3 numbers. And so when I add those, just like we did with the previous section when we did the adding, right? At most, at least. Remember we did those with the shortcut with usual and usual. We have to add them. Well, we have to do it here. We have to add 2, the 1, and the 0. So I'm going to add them up. And when I add them up, I get 0.7969178. If I round it off, that would be 0.797. Okay. All right. I hear one of you saying, wait a minute, I see that number, sir. I see that number. I see that 0.7969178. Yes. Oh, yes, yes. That's right. That's right. It's right there. Oh, that's right. Remember, we talked about this was the cumulative. These three numbers, I can't get it. These 3 numbers equal to that number. That's right. So you're saying that fewer than 3 is equivalent to 2 or fewer. That is correct. That is correct. So if you want to do a translation, fewer than 3 is really 2 or fewer. Or someone said at most 2. Yeah, it's also at most 2. That is correct. Those are 2 different translations. Very good observation. So fewer than 3 is equivalent to 2 or fewer, which is also equivalent to at most 2. So what this 210 means, I have to find the exact of 2 plus exact of 1 plus the exact of 0. Exact of 2 plus exact of 1 plus exact of 0 equals 0.7. All right, 18. All right, 18. N is still 8. P is 0.20. And X is, let's go to 18 and see what 18 is asking us to find. 18 says, find the probability that the number of X correct answers is no more than 2. All right, specifically, no more than 2. I gotta write that specific title. No more than 2. Okay, so I gotta write probability P parentheses no more than 2. Okay, I don't see a no more than 2 on my handout. I don't see it anywhere. If I get through my handout, I don't see that terms no more than 2. No, exactly at most. No, it doesn't have no more than 2. All right, so I gotta think. What is no more than 2? It can't go beyond 2. What are numbers that are before 2? That's right. No more than 2. That's right. It is 2, 1, and 0. 2 is the max. No more than 2. It can't go above 2. So it's 2, 1, and 0. Hey, that's the same thing that we got for the other one. Huh. 0.797. Wait a minute. That's also equivalent to at most 2. So yes, this is the same as at most 2 which is also equivalent to 2 or fewer. Interesting. It has the same answer, the same steps. Interesting. All right, number 19. All right, so n is still 8. P is 0.20. And let's see what our x value is for number 19. So for number 19, my x is no correct answers. No correct answers. No correct answers. What does that mean? No correct answers. Right? So no correct answers means exactly, I can't spell exactly, exactly 0. Right. So I gotta do exactly 0. So the probability of exactly 0, right? We're gonna go and show you go down. Exactly. Supposed to be an 8.20. No correct answers means exactly 0. So probability of exactly 0. So let's go to stat disk and plug it in. Right, and 8.2. Now, I can't use my special button and put 0, because if I put 0, it doesn't, for some reason, it does not give me that specific row or 0 for my random variable. It just doesn't work. So I have to call someone and talk about that. So we'll have to do this one manually. So we'll have to go to the 0 row and go to my exact. And so here it is. Here's my exact. My P of X column represents the exact. So my answer for this would be, I rounded 3. I don't know why it isn't. All right, hold on. It's not letting me highlight it. For some reason I wanted to highlight. See, I wanted to do that, but it won't let me do it. Come on, work. Anyways, it's that number. I'm gonna round it. I'm gonna round it to 3 places. So that equals 0.17. What? Sorry, 0.168. 168 is my answer for exactly 0. Okay. $20. N is still 8. P is 0.20. X. Let's find out what X is. X. For some reason, my 8s are not coming out clear. I apologize. All right, so let's put 8.20. Here's number 20. My X is going to be equal to at least 1. Oh, I know where that one's at. At least 1. All right, so probability of at least 1. Okay, so let's see where that's at. At least 1. Well, this one I can do on stat disk. Let's see, stat disk. Okay, now this one I can put 1. All right, so which column is my at least? Is it the, now it comes out highlighted. Is it this one, or this one? That is correct. It is the third, at least. At least is the last column And so at least one is going to equal to 0.832. 0.832. Very simple. You just have to use your sheet that I gave you and just match it. Your reading comprehension is going to be vital. So you'll have to read, extract, identify. Read, extract, identify. No computing. Stat disk will compute. All right, so let's do a couple of word problems. We can do number 25. Let's do number 25. Oh, I was noticing about the twos. All right, 25. In the legal case, in the classic legal case of Wittes versus Georgia, a jury pool of 90 people was supposed to be randomly selected from a population in which 27 were minorities. Among the 90 people selected, 7 were minorities. Find the probability of getting 7 or fewer minorities if the jury pool is randomly selected. Is the result of 7 minorities significantly low? Okay, so let's write down what they provided us in this problem. So for number 25, my N is 90. My P, it says 27%. Recall that I have to change 27% to decimal. So that would equal to 0.27. And my X, you gotta write down exactly what it says. Does it say exactly, fewer than, more than? What does it say? It says find the probability of getting 7 or fewer. Okay. All right. So I think I got everything. Now I'm going to go to stat disk and I'm going to enter all these numbers in and find my probability, my P parentheses 7 or fewer. And I'm going to enter it. So my N is 90. Uh, 0.27. And it's 7 or fewer. Okay, evaluate. I'm looking for 7 or fewer. Well, it's not the ones that I had titled exactly at most or at least, but it does say it within the parentheses at the title of the column. So I think it's this one, X or fewer. That's it, 7 or fewer. And so my answer is going to equal to, oh, that's a very small number, which means my answer is going to be 0 plus. Okay, so we answered that question. And then there was another part. I think it asked us, is the result of 7 minorities significantly low? Oh, remember, the shortcut to determine usual and usual. Remember, the shortcut was probability of X or fewer had to be less than or equal to 0.05. Right? So we already got my answer. This was 0 plus. This here was 0 plus. So is 0 plus a number smaller than a nickel? Yes, it's true. So it is unusual. Okay. All right, let's do another one. Let's do, all right, so we do see you later or too young to text. Yeah, we'll do see you later. Okay, so Number 27. Based on a Harris Interactive poll, 20% of adults believe in reincarnation. Assume that 6 adults are randomly selected and find the indicated probability. Okay, so I believe for this problem, we're going to be using n to equal 6, because I think it says 6 adults. And we're going to be using p to equal 0.2. That's what 20% is, right? 0.2. So we're going to be using that. And then I think A will give us our X. So A says, what is the probability of exactly 5? Okay, so I gotta find the probability of exactly 5. Okay, so this is what I wrote down. N is 6, P is 0.2, A says exactly 5, so I gotta find the probability of exactly 5. So I'm gonna enter this, and 5, and I gotta find the value of 5 in the exactly column. So, let's see, 6.20, exactly 5. All right, 5 exactly. Here it is. It is under the P of X column. So if I round this one off to 3 places, that would equal to 0.002, not 0 plus, because this one has enough digits to round 002. Like that. Okay. B. I think B is asking find the probability. I'm using N 6, P is 0.2, and my X is what's the probability that all of the selected adults believe in reincarnation? Well, what's considered all? What's all? Oh, there were 6, all 6 of them. Exactly 6. Exactly 6. So I gotta find the probability of exactly 6. Okay, so let's plug it in. My stat disk. I'm gonna plug in 6. And exactly, this one's going to be 0 plus. That one is 0 plus. I don't have enough digits to round, otherwise it'll give me zeros, and it's not true. I got small numbers, so it has to be 0 plus. Okay. Zero plus. Okay. C. What does C say? Find the probability that at least 5. At least 5. So I gotta find the probability of at least 5. All right, so let's go to stat disk. Plug in the 5 here. And which value represents the which column represents at least? Second, third, or fourth? The fourth, correct. So my answer is 0.002. This one's not 0 plus. This one is actual numbers I can round off to 002. And then D, I think D, I don't think it's asking for a probability. I think it's asking if 6 adults randomly selected, is 5 a significantly high number who believe in reincarnation? Oh, they're asking, is part C a value that's significantly high? Let's see. That's a good question. I don't know. Let's see. Significantly high. What was the definition of significantly high? Oh, it's 5 or more. I need the probability of 5 or more or greater. Oh, that's at least. That's the at least. 5 or that's 5 or more. Yeah, that's right. It's at least. Sorry. Yeah, you're right. So yeah, it was right. Is the result from part C? I want to know, is the probability of 5 or more a number less than or equal to 0.05? That's what at least means. Ah, okay, so let's see. I want to for it. So what was my answer to letter C? My answer to letter C was 0.002. Is 0.002 a number smaller than or equal to 0.05? Yes, it's true. That means it is unusual. Cool beans. Okay, awesome. All right, so now the last part of 5.2 is going to ask us to find the mean, standard deviation, variance, minimum usual, and max usual. For a binomial distribution. Okay, now if you're going to use stat disk, you need to know the N and the P. That's all you need to know. The N and the P. We don't need the X. That's all we need to use stat disk. That's all we need to know. All right, so my mean, remember the symbol, mean is mu, standard deviation is O, and variance is O squared. And you probably didn't even notice this, but when you did use stat disk, every time we were doing it, it computed it for us automatically without us even knowing. Go back to our stat disk. Do you know when I did the previous problem where I put 6.20 and 5 and I hit evaluate? If you scroll, you see, if you click on results right here. I can't click on it. results. Bam! It gives you the mean, the standard deviation, and the max. But even though it does give us the values automatically, we need to round these to the tenths. All answers to the tenths. Okay, we gotta round to the tenths. All right, so let's do a problem. All right. So the one in your book, you can do number 29. All right. Okay, so it says in exercise 29 to 30, assume that the different groups of couples use the XOR method of gender selection and the couple gives birth to one baby. The XOR method is designed to increase the likelihood that the baby will be a baby girl, but assume that the method has no effect. So the probability of a girl is 0.5. All right, 29. 29 says, assume that the groups consist of 36 couples. All right. So we know off the bat, number 29, that our N is 36. What is P? What is the probability of getting a boy or girl at birth? Ah, that's right. It's 0.5. Right. Now, let's look. What does A say? A says, find the mean and standard deviation. Oh, we didn't have to find variance? Well, I think that's something. All we need to do is find the mean and standard deviation. All right, so let's plug in my N and my P in StatDisk and then click on results. Okay, there we go. So then I click on my N is 36. My P is 0.5. I don't need to fill in this. I don't need that number. I'm going to evaluate and then click on results. Can't get it. Results. Results. Bam, there it is. And I gotta round it off, round the 2 off to the tenths. So 18.0 is my mean. Standard deviation is 3.0. Let's do variance. What the heck? Variance. Might as well, right? O squared is 9.0. There is part A. Simple. You gotta click on result, people. After you click on your N and your P, don't fill in anything on the X value. You hit evaluate and make sure that you click on results. You gotta click on results. I didn't do it last time. I'm like, where did it go? Did they take it off? Yeah, you gotta click on results. All right, and then so there's my answers. 18.0, 3.0. And I think B is asking, let's see what he asking. He is asking, use the range rule of thumb to find the values separating the results that are significantly low or significantly high. All right, so this one's asking you, what is the max value and what's the minimum value? That's what it's asking. So you'll recall what the formulas were for min and max. So max value, max usual, minimum usual. Usual, min usual was mu plus 2 times the standard deviation, and the minimum was mu minus 2 times the standard deviation. Okay. And we plug in the numbers. So my mu was 18.0 plus 2 times 3.0 And then the other one was 18.0 minus 2 times 3.0. So I'm going to compute it. 18.0 plus 6.0 is 24.0. And the other one's 18.0 minus 6.0. That is 12.0. There's my max and minimum. And I think C is going to give you a number, and you place it where does it belong? Does it go in the usual, which is in between, or is in the unusual? It goes above, it exceeds the max, and or goes below the min. Let's see, what is the number that they're wanting us to test? They're asking us to test. C, is the result of 26 girls a result that is significantly high? Where does 26 fall? Where does 26 fall? That's right. 26 exceeds. 26 goes way over here. So that means 26 is unusual. Because it exceeds the max usual value. Yeah, it was way above there. There you go. And I think 31 should be similar.